So here's an example of integration by substitution. The expression that you want subbed in by u in this case is 4 minus x. du in this case is going to be negative dx based off of rules of integration that we already know. And in order to get this to more closely match what we have going on in the original expression, we're going to divide both sides of du equals negative dx by negative 1. Just rearrange that equation real quick. Negative du is equal to dx because we don't have a negative inside the integral in the beginning. And now we can just substitute. So the integral of 1 over the square root of 4 minus x dx becomes the integral of negative 1 over the square root of u du. The negative coming from the negative that's over here. This integral is going to be equal to negative 2 times the square root of u. And now we just sub in 4 minus x back in for u, and you wind up with negative 2 times the square root of 4 minus x, and then plus c. And there's your answer. So our second example of integration by substitution is going to be the integral of the natural log of z squared over z, and u in this case is just going to be the natural log of z. That's pretty obvious to see because of the fact that you have the derivative of the natural log of z in the original expression, which is 1 over z dz. So now you can substitute and rewrite the expression as the integral of u squared du. And that goes to u cubed over 3. And now you can sub ln of z back in for u. And you wind up with the natural log of z cubed over 3 plus c. And that's your answer. So here's another example of integration by substitution. So you're not going to want to put in for u the cosine of the square root of x in this case because of the fact that you don't have the derivative of the cosine in here, which is negative sign. So instead, you're going to, for u, put in the square root of x. And you'll see that that makes a lot more sense because the derivative of the square root of x is 1 over 2 square root of x dx. To make this more closely match what we have in the actual expression, we multiply both sides by 2. So now we have instead 2 du is equal to 1 over the square root of x dx. And now we substitute. That's just going to give you 2 times the cosine of u du, and that easily enough just goes to 2 times the sine of u. So that's just going to be 2 times the sine of the square root of x plus c, and that's your answer. The next example of substitution is the integral t over 1 plus 3t squared dt. In this example, your u is going to be 1 plus 3t squared. That's good because you have a form of the derivative of that in the original expression, and the derivative of that is 6t dt. To make the derivative that you took more closely match what you have in the original expression, because there's no 6 there, you just divide both sides of this by 6. So now you have 1/6 du is equal to t dt, and you have t dt in your original expression. So now you substitute, and you wind up with the integral of 1/6 du over u, and you can just pull out the 1/6 from that, have 1/6 times the integral of du over u, and then integrate to have 1/6 the natural log of u. Then you substitute 1 plus 3t squared back in for u, and that's going to give you 1/6 the natural log of 1 plus 3t squared plus c. And that's your answer. So here's another example of integration by substitution. In this case, you're going to sub in for u the sine of x squared. And that makes things easy because we have nearly like the exact derivative of that in the numerator, except for the 2. Because the derivative of sine of x squared is 2x times the cosine of x squared dx, due to the chain rule. And from there, to make this more closely match what we have in the original expression, we just divide both sides by 2. So now we have du over 2 is equal to x times the cosine of x squared dx. So now we just substitute, and you've got the integral of 1 over 2 square root of u du. That's really nice and neat because now we know that the anti of that is the square root of u. Now we sub u back in, which is the sine of x squared, so it's the square root of the sine of x squared. Just make that a little neater. The sine of x squared plus c. And there's your answer.